to know, what is this all about? And we're taught one thing in school, it seems. We're taught a different thing in church. And when I do presentations like this, inevitably somebody is nervous. Is he going to talk about evolution? Is he going to talk about creation? Am I going to get preached at? What is this going to be about exactly? So we're going to look at both ends of the spectrum tonight and kind of see where the evidence points to. And we want to say what this is not also. This is not a debate. I know that there may be some that are adamant one way or the other on this subject, but due to, I want to be sensitive to your time. Are you guys busy? Are you busy? I'm busy, right? But we want to be sensitive to your time. So any questions or anything, you'll have opportunity. If you think of something, you can email it to me, brandonseniorseminars@gmail.com. Virtually all of your questions will be answered throughout this presentation during one of these sessions. Tonight we are going to look at time and space. We're going to take a look at a brief history of evolution, the Big Bang and its laws, and geology. And let's take a look at a brief history of evolution. Who's the guy that you normally think of with evolution? This is the poster child, Charles Darwin. We're going to take a look at some definitions here. Let's take a look right off the internet, right off of Merriam-Webster.com. We want to know, what is evolution? It's a theory that the various types of animals and plants have their origin in other pre-existing types, and that the distinguishable differences are due to modifications in successive generations, also the process described by this theory. There's one definition. Another definition is from Merriam-Webster.com, a process in which the whole universe is a progression of interrelated phenomena. And we want to look at the other side of it also, creation, the definition of creation, freedictionary.com, the divine act by which, according to various religious and philosophical traditions, the world was brought into existence. And in the Bible, that I know of, it's the only place that one person claims to have created everything. Genesis chapter 1, verse 1, in the beginning, God created the heavens and the earth. And let's see here, I think it was 2 years ago, I was given this presentation at a middle school, and it was open to the public also, and a few people came up to me, they asked, well, how old is this idea of evolution? I usually think it goes back to Darwin, and surprisingly enough, it goes back much further than Darwin. It goes all the way back to even pre-Socrates is the idea, and Socrates was around 469 to 399-ish BC. And really from then, for about the next 2,000 years, not a whole lot of changes in that theory took place. By the way, when you hear evolution as a theory, my intention here is to educate on kind of both sides. A theory, it's more appropriate to say that it is a hypothesis to determine an untestable past. In 1744, Jean-Baptiste Lamarck was born, and he laid the foundation of modern evolutionary theory with his concept of inheritance of acquired characteristics, which was later given the name Lamarckism. Anybody here heard of Lamarckism? And this is the idea where, let's say a horse is reaching up to some vegetation on a tree, the vegetation gets higher, and the horse reaches, and eventually you come up with a giraffe. And this idea is not really even taught officially in textbooks anymore, but kind of the process really still is. And it's really been disproven. Robert Chambers, 1802 to 1883, was a spiritualist who regularly communicated with spirits. As a result of his contacts, he wrote the first popular evolution book in all of Britain called The Vestiges of Creation. Now that date that book came out there, 1844, may ring a bell to some of us, and that was a turning point in really the human race, and maybe at another chance I'll get to expound more on that. But it's interesting that the first popular book is tied to a person that was involved in spiritualism, and the idea of vestiges of creation. Vestiges is the idea that we have organs and muscles that we don't need anymore, like the coccyx bone, the the fibula, the appendix, and now they know this has all been disproven because the appendix they know now is very important to the immune system and other functions. And the coccyx serves as an attachment site for tendons, ligaments, muscles. It also functions as an insertion point of some of the muscles of the pelvic floor. The coccyx also functions to support and stabilize a person while he or she is in sitting position. So all these that they used to think were kind of leftovers that aren't necessary anymore are still very important to us today. Is anybody in here, what are we majoring in here? Anybody majoring in medicine or anything? Biology? What do you have down there? Pre-med. Pre-med? Okay, so this is kind of, you could probably teach me on some of this stuff then. Maybe we'll have you come up here later. And then next was a guy by the name of Charles Lyell, and he laid the basis for the modern theory of sedimentary strata. Even though 20th century discoveries in radio dating, radiocarbon dating, and missing strata, and overthrust, which is old strata over top of more recent strata, have nullified the theory. This is where we're going to spend much of our time tonight. And when I do these presentations, I realize I'm hitting, usually there's highly educated, and then there's people with maybe no education that I'm talking to. So I got to hit the broad spectrum. So if I'm going something that's very, very deep, hang in there, it'll get easier. But if I'm getting kind of mundane and maybe it's not interesting enough, hang in there, it's going to get deeper. And of course, we have to talk a little bit about Charles Darwin, who published his book, The Origin of Species, November 1859, from which much of the modern evolution is based on. We're going to take a look tomorrow evening a little more inside the personal life of Charles Darwin and see how evolution and survival of the fittest worked out in his life and his family. And there's this bridge, this gap between evolution and creation. Many people say that to say anything about creation, it shows some sort of a lower intelligence level. I was walking and talking with somebody in Arizona, and they flat out said, I can't believe there's anybody so stupid on planet Earth still to believe in creation. And I said, well, why didn't you come to one of my creation seminars and we'll see what the evidence points to? And they never did come to it. But we're going to see what the evidence points to tonight. Let's take a look at some scientists that were creationists. Number one, Blaise Pascal was a creation scientist. Isaac Newton, William Herschel, Louis Pasteur, and George Washington Carver. And I can give you an entire list of modern scientists today that are still creation scientists. You just probably wouldn't know who most of them are. So to say that science has no foundation on anything to do with God or creation is really not entirely accurate. And then there was a poster that came out a few years ago, Atheism, Good Enough for These Idiots. And they really try to say that, all these guys were atheists, and really if you want to reach the higher level and to be smart and really be something, you have to take God out of the equation. But in actuality, when each one of these people were studied after this came out, turns out Abraham Lincoln was not an atheist, Carl Sagan was not an atheist, Thomas Jefferson, Benjamin Franklin, Mark Twain, Albert Einstein, not even Charles Darwin was an atheist. There's only one atheist that's actually pictured on here, and it is Ernest Hemingway. Anybody know what happened at the end of Ernest Hemingway's life? And we have any readers here? Took his own life, suicide, shot himself. And there is this tension with creation, evolution. Really, what is the end result? We want to know what is the beginning, what is the end. That's what we're going to find out today. We're going to take a look at the Big Bang and its laws. And to understand the survival of the fittest, we have to look at the arrival of the fittest. We have to look at the origins. That's what we're going to spend time looking at tonight. And here is a video that kind of explains the view of evolution at large. So this is a short couple-minute video we'll look at, and then we'll spend the rest of the presentation breaking it down.
In the beginning, there was nothing. A vacuum, void, empty space. And in this empty space there emerged a primordial fireball. Billions of years ago, this fireball exploded. This explosion generated all space, energy, matter. The universe expanded rapidly, producing electrons, neutrinos, photons, and quarks. Soon, this energy began interacting, forming protons and neutrons. Matter continued colliding and interacting. Over time, the first simple elements formed. These elements also collided as the primordial soup continued to expand. Cosmic and particulate evolution continued, and stars began to group, forming into the earliest galaxies. And then, just 5 billion years ago, something wondrous occurred. Within a cloud of gas in a spiral arm of the Milky Way galaxy, our sun formed. This new star gave birth to planets, moons, and asteroids. One of these planets, known as Earth, developed an atmosphere. Earth's environment, believed to be filled with volcanic eruptions, lightning, turbulent weather, mixed atoms and energy to create the first simple living cells. Then, through millions of years of mutations and natural selection, algae, jellyfish, and flatworms appeared. As evolution continued, fish appeared in the seas on planet Earth. Some of these fish developed into amphibians, and through natural selection changed into reptiles. A segment of these reptiles evolved into a variety of creatures, including mammals. Some of these mammals became primates, and then, just 600,000 years ago, an isolated group of these primates evolved into man's earliest ancestors. This is our amazing evolutionary heritage. And evolution continues today as we evolve to our even higher destiny in the universe.
Okay. If you just came in, welcome, welcome. You haven't missed too much. We're right at the beginning here. So that's sort of what the basis of evolution, and we want to know, is it reasonable? For something to be reasonable, there has to be reason. That's what we want to know. This is basically what they say the Big Bang Theory is, that an infinitesimal speck exploded, and then over up to 15 billion years or so, created everything that we have here today. And we want to see what is the basis for that. Where do we get the idea of any of this? And this is based largely on the expansion of the universe, which is seen through the redshift here. There's about 5 different versions of redshift, or 5 different forms of it. This one that really is the clincher here is the Doppler theory of redshift. And what is, redshift waves are stretched and objects are moving away. This is at the opposite ends of the light spectrum. If it's closer to the red, things are moving away. If it's closer to the blue, things are moving toward us. And we want to see, are things moving away as the universe expanding? Well, this is what that theory is based on. But then this guy by the name of Albert Einstein popped up on the scene, and he noticed and predicted that gravity could bend light. So as light travels toward us from giant stars, it passes other stars, which slows the beam, causing the spectrum to shift towards the red. So what we should see, if there was a Big Bang, you should see everything moving from where the Big Bang started, right? Doesn't that make sense? It shouldn't be moving away from planet Earth. Let's continue here. If you look out in the starry night, this is what you would see, something like this. You would see huge concentrations of stars. This becomes a problem with the Big Bang theory. And all this, remember, came from one infinitesimal speck and then exploded, created everything that we have here today. If it was that Big Bang, it should be uniform distribution. But we have clusters, we have galaxies, and this is a big problem. Instead of uniform, you see super galaxies clustered together, spiraling around each other. Now remember, the Big Bang Theory, according to this, the universe was created between 10 and 20 billion years ago from a random cosmic explosion. Now, this next quote I'm going to show you is, it's made from a scientist in a scientific journal. Take a look at this. The observable universe could have evolved from an infinitesimal region. It's then tempting to go one step further and speculate that the entire universe evolved from literally nothing. So now where it was an infinitesimal speck exploded and created everything, now it's backed up to nothing exploded and created everything that we have here today. For the Big Bang Theory to be accurate and correct, it has to violate laws of nature. We have to make some assumptions, some philosophical assumptions. This says we're lost. The foundations of the Big Bang models would crumble away. We'd be left with no explanation for the Big Bang Theory or galaxy formation or the distribution of galaxies in the universe. Now remember, let me back up a slide or two. Everything should be shooting out in linear motion, right? Nothing should be circling, nothing should be going around if that were true. But let's take a look at this here. Let me back up. There was this article that came out, I think this was just a month or so ago. February 28th, 2015. And it was entitled, Big Bang Deflated. The universe may have had no beginning. So it went from a infinitesimal point exploded, created everything, then it was nothing exploded and created everything. And there's been so much controversy over this, now they're saying there was no Big Bang at all. Our theory suggests that the age of the universe could be infinite. So when we say that the universe begins with a Big Bang, we really have no right to say that. And I should make another disclaimer here. You'll see me reference science from time to time, and this, I am not against science. I am not opposed to science. You should know I'm a creationist. I believe that God created us with a purpose. And I actually used to be an evolutionist. I used to believe that we all came from apes, monkeys, and the Big Bang and the whole thing. But what was it that changed my mind? Let's continue to see. This is something called the Pleiades galaxy, and this is, it's also known as the Seven Sisters. This is a bound cluster. Okay, the gravity inside is equal to the gravity outside. It's not expanding or contracting. It just kind of stays as it is. And this here is the Orion Nebula. The systems in the belt of Orion are flying apart at breathtaking speed. So how does this compare with what was written in the Bible in Job chapter 38, verse 31? Can you bind the cluster of Pleiades or loose the belt of Orion? Now, how is it that somebody thousands of years ago, before any telescopes or really any science, was able to write something like that unless there was somebody giving that information to him? The Big Bang Theory also violates the law of conservation of angular momentum. Here you have the Andromeda galaxy, and the law of conservation of angular momentum is this. Planet stars moving, everything's moving in circles, right? Even planet Earth is moving in circles. We should see that linear motion, but it's not. Everything is circular. So then they thought, well, maybe that original speck that exploded, which then is nothing that exploded, and then there's no Big Bang at all, maybe that was turning in the beginning, and then when it exploded, everything else was turning. Think of something like a merry-go-round. Right? Anybody been on a merry-go-round recently? I have a little 6-year-old daughter, and I take her to the park, and she runs right for the merry-go-round. It is like the most dangerous piece of equipment on the playground. And imagine my daughter's on the playground, on the merry-go-round, and then this bully comes over and spins the merry-go-round till it's going at like lightning speed, right? She can't hang on anymore, flies off, and is spinning. So the idea was maybe that original speck was spinning, exploded, and then kept everything spinning also. Advocates of the Big Bang Theory proposed that the singularity that blew up in the Big Bang was spinning before it exploded, thus everything within it was spinning as it flung out. However, some galaxies, planets, Venus, Uranus, and Pluto, and many moons are spinning backwards. They call this retrograde motion. In other words, they're spinning in the wrong direction. And some have retrograde orbit around their planets. The planets spinning one way, and moons are spinning the other way. Jupiter, Saturn, Uranus, and Neptune have moons orbiting in both directions. This creates a problem. This is galaxy NGC 4622. Appears to be rotating in the opposite direction to what they expected. Here you have an entire galaxy spinning in the wrong direction. Now, what sort of force would it take to stop a planet and then spin it in the other direction? What would happen if that happened to planet Earth? Everything would fly apart, wouldn't it? What would it take to stop in a galaxy and spin it in the other direction? We just don't see those forces at work. The Big Bang Theory says the universe came from a little speck and eventually turned into atoms, even though matter versus antimatter should have destroyed them. This all came primarily from helium. So that Big Bang came, and then it was primarily helium, and then there was dust and reconstruction and stars, and then they exploded and then recreated and came to rocks. So basically, we all came from rocks, right? So next time you're at your family reunion, don't forget to invite Grandma and Grandpa to the family reunion, according to this theory. Here you have a chart that is measured in millions of years, right? Dust reconstructed itself and eventually formed what is seen here today. And we want to know, is that feasible all by itself? Remember, for something to be reasonable, there has to be reason. For there to be reason, there needs to be the evidence. Is it possible, driven by a force called natural selection? And this is categorized in millions of years. Life came into existence, right, 10 to 20 billion years ago there. And then not much happening here. And then, boom, right in the Precambrian layer. This is called the punctuated equilibrium, the Cambrian explosion. Everything appears or seems to appear all at once here. And this is what is known as Darwin's dilemma. This is what Darwin had a big problem with. Why is there almost nothing here and then, bam, everything appears all at the same time? This is something that needs answering, and we'll try to take a look a little bit at it tonight. Let's take a look at planet Earth, our place in the solar system. And here you have, now this is an outdated video now. It talks about 8 planets. We know we have 9 planets again. Earth is perfectly situated in the solar system. If it were any closer to the sun, there would be too much heat, too much radiation, everything would die. If it were any further away, it wouldn't be hot enough, everything would freeze, there would be no life. And even the moon, it is situated perfect for life to function here on planet Earth. The moon controls the tides. If it were any closer, there would be tsunamis. Everything would be destroyed. If the moon were any further away from planet Earth, there wouldn't be tides. The water wouldn't churn. It wouldn't oxygenate. There would be no life. We are situated exactly where we need to be. And let's take a look at even our calendar. Even our calendar speaks of creation, seems to. We have 365 days in a year. Why? Because that's what it takes for Earth to orbit around the sun, right? We have 28-ish days in a month because that's what it takes for the moon to orbit around the Earth. We have 24 hours in a day because that's what it takes for the Earth to rotate on its axis. But why do we have a 7-day week? It's not seen anywhere in the cosmos like the rest of the calendar. Everything is situated perfectly, and they used to think that it's because of the 7-day week has been imposed on human culture for so many years, and they used to track it back to Babylon. Babylon is not known for the number 7. Babylon is known, how many of you know this, for the number 6. 360 degrees in a circle, 60 minutes in an hour, 60 seconds in a minute. All that comes from Babylon, 6, not 7. Let's take a look at this. So we're on, where are we? We're on, it's the first day of spring, and we have a snowstorm. So we're on day number 6 here, Friday the 20th. Take a look at this. How many of you are familiar with new sciences? There's a new science, a relatively new, called chronobiology. At first glance, it might seem that the weekly rhythms developed in response to the 7-day week imposed by human culture thousands of years ago. However, this theory doesn't hold once you realize that plants, insects, and animals other than humans also have weekly cycles. Biology, therefore not culture, is probably at the source of the 7-day week. Science is even recognizing this. And our bodies operate on a 7-day cycle. They've tried a 10-day week in the past. I think it was in Europe. Problem was people were getting sick, and animals and livestock were dying off. We're not designed to operate on 10 days. We're designed to operate on 7. And God has put us on a circa septem calendar. Let's take a look now. We may get into a little bit of the boring stuff here. We're going to get into geology and take a look at some of the rocks here. Geologists divide time into time zones, beginning with macroorganisms. You have the Cenozoic, Mesozoic, the Paleozoic era, and so on. The paleontologists say that we can see this record of time in the rocks. And geology concerns itself with how the matter forms on this earth and its age. We do have a paleontological record, but yes and no to the geological record. Nowhere in the world, this is important for you to realize this, nowhere in the world do you have a complete record of the geological column. You cannot go slice a mountain open somewhere and see the entire history in order. It doesn't happen. It's not there. So then they use radiometric dating to try to date and age rocks. I was looking in a dried up riverbed when I was in Arizona, and there was an archaeologist that he was digging. And we were talking a little bit, and he said, "Hey, do you know how old this is?" And I said, "No, tell me how old this is." And he said, "This is millions of years old." And I said, "How do you know it's millions of years old?" And he said, "Because of radiometric dating." And I said, "That's interesting. But is radiometric dating accurate?" And this is based on the decay of natural occurring radioisotopes in rocks and minerals. An unstable parent isotope decays into a stable daughter isotope. And this decay process is used to determine the age. However, some assumptions must be made in radiometric dating. Assumption number 1, you have to assume that the rate of decay and half-lives have remained constant over time. You have to assume that there's been no change or fluctuation in the way that it's been decaying. Number 2, the clock was set to 0 when the material was formed. How can I know how old you are? What information do I need to know how old you are? I need to know your birthday, right? I could guess, but I'm terrible at guessing. You have to know when something started. You have to know when the rock started to then be able to track its decay rate. And we have to know that we are dealing with a closed system. You have to assume that the rock has not been touched, modified by any outside forces the entire time of its existence. All of those given, radiometric dating is a perfect process. However, in light of these assumptions, it means absolutely nothing. And let's take a look here at the example of a candle. If I take a candle and I want to know scientifically how old this thing is, need to know how long the candle was originally, and need to know how fast it had been burning, right? If I blow on this candle, it's going to burn faster, isn't it? If I cut the candle, that's going to manipulate the age. And I have to know that it hasn't been tampered with. I need to know that the candle hasn't gone out and then been restarted again. And the same thing with a rock. You need to know the starting conditions, you need to know the decay rate, and you have to know the history. So for this to be accurate, this rock, if you wanted to know how old it was, you would have to be there when it was made, when it was born, and then it would have to be placed into some sort of container where it couldn't have been touched or manipulated, and then measured that way. Is that making sense? Okay. Here you have the geological time scale. Remember again, the geological time scale is not complete anywhere on Earth. And here each layer in this model represents periods of time. So you could say each layer of the Earth represents periods of time, or you could say each layer represents material, simply material. And you do see different animals at different layers, and we're going to see why that is tomorrow night. Dinosaur shocker. This is from the Smithsonian Magazine, May 2006. Probing a 68 million year old T-Rex, Mary Schweitzer stumbled upon astonishing signs of life that may radically change our view of the beast that once ruled the earth. And what happened was she had cracked open a bone accidentally and she found gooey stuff on the inside. Now up to this point, what she found was a heme, and heme deals with oxygen and blood and it gives it its color. And the red blood cells, up to this point, they thought could only last 1,000 to 3,000 years. Now they find this and they say, oh, well, it can last 68 million years. You've got two choices. Either the dinosaur, either the red blood cell is 68 million years old or the dinosaur is not. We're looking at how things are dated and timed. We're going to talk more about dinosaurs tomorrow morning at a special presentation, and we'll give the information about that. Let's talk about the flood a little bit. All this tonight is we want to understand the timing. How is the timing to be understood? Any of you that have read the flood account, you can track it easily throughout the Bible. All you got to do is read and track it down. And you usually hear that Noah was on the, or it rained 40 days and 40 nights, right? Usually that's about where people leave off. But really, did you know that he was on the boat, on the ark, 1 year and 17 days? It rained for 40 days and 40 nights. Water was coming from the sky. The earth broke open also. Water was coming from below. This was a catastrophic event. The floodwaters peaked. They didn't even peak until 5 months. And what this did, all this flood, all this water, what that would create is a lot of mud. So what we see in the geological column is not necessarily time. What we see is layer of material, layers of mud. Anybody here ever been to the Grand Canyon? Two people have been to the Grand Canyon, and you guys, I've been there myself also. When you get there, it is enormous. However big you think it is way bigger than that. Huge. And you can see here, now notice each layer here is perfectly flat. Perfectly flat. Each seam there is perfectly flat. There are no erosion channels in between the layers. If you go down to the bottom of the Grand Canyon, you'll see a sign that talks about an unconformity. An unconformity is a surface of contact between two groups of unconformable strata. What does that mean? That means you have a layer of material, and then there seems to be an entire layer of material missing and another one. Think of no burger between the buns, right? And this whole layer has been taken away. In fact, we have it dated like this. Right here you have over 100 million years missing there. Here you have 14 million years missing. Right here you have about 6 million years missing. Now what in the world happened to that time? What in the world happened to that layer? And science says that the only thing that can take away material like that is erosion, right? Water, rain, the elements come, take away, and displace it somewhere else. When you go to a river, usually they're not crystal spanking clear, are they? Usually they're murky, they're muddy, and why is that? Because as the water's flowing, it's taking material with it. And if we take the lowest rate of erosion in the United States, it's about 6 centimeters per 1,000 years. The highest rate of erosion is in the Himalayas. It's 2 meters per 1,000 years. In other words, every 1,000 years, 2 meters of material are being washed away. Remember, the only thing that can take these layers away are erosion. Using the lowest level, 10.2 million years is enough time to wash away the entire North American continent into the ocean. Over 100 million years of time, using the 6 centimeters per 1,000 years, 100 million years is enough time to wash away the entire North American continent 10 times over. What happened to all of the material? Here you see it again, completely flat. Why are they completely flat? You see some coal seams there. And again, the only thing that can tear channels like that, it's erosion, right? This is what erosion does. It tears into the landscape. Take a look at this. This was taken at, I think it was Cedarburg area in South Africa. So here you can see really nicely 3 layers there. And what science says is here's a layer, millions of years, and then there's another layer, millions of years and another layer. And what they say that the trees, the material, and time and seasons break down, and they say that each layer here was the surface of the earth for this long period of time. Perfectly flat, not so flat at the top. Here you have it again, flat, but it's not quite flat right here. Flat here, and then what seems to happen there? Here's another one. Here's a guy standing there for size comparison. Flat, and then what happens there? What happens at the top? At the top, this is what erosion does. It tears it away in an uneven manner. Now, let's explain this in a different way. What happened to that layer, that material, that time period? Let's say I have 3 buckets here, right? Say I have one big bucket of black mud, right? And I throw it here and it goes out all over this entire room, covers the entire room. And let's say I have a yellow bucket. It's smaller, and I just kind of go, whoosh, and it just kind of covers the first half right here. And then I have a big red bucket, and it covers about 3/4 back. Where am I going to have 3 layers? In the front or in the back? Going to be right here in the front, right? Why is there not 3 layers in the back? Because there simply wasn't enough material to make it all the way to the back. This is why we see this situation right here. And there simply wasn't enough material to cover it. The survival of these paleoforms is in some degree an embarrassment to all of the commonly accepted models of landscape development. So this unconformity, this millions of years missing, science says it is an embarrassment to the theory because it's unexplainable. The outcrops were excellent, but even the closest inspection failed to turn up the precise position of that 15 million year gap. Why is there a gap and I cannot see it? Where did the material go? This is a question that needs answering. Here you have it again. It's nice, perfectly flat. These are coal seams right here. And again, the coal seams are there because of copious amounts of natural material, trees, leaves, and it breaks down. What happens in fall? When the leaves fall, do they stay around for a very long period of time, or do they blow away and go wherever the wind takes them? Leaves don't fall and just kind of stay there, do they? How about trees? Do they just fall and stay there, or do they get broken down? They don't stay there for millions of years, do they? So how did these layers of coal form? Let's take a look at some fossils here. Anybody ever seen any fossils? Here's a leaf. You can tell the veins nicely right here. Here on this one, you can see the points and jagged edges and really nice preservation. How do fossils happen? Science tells us that the leaf would have to fall, and then it would have to sit there for millions and millions of years for that to turn into rock. And that doesn't, do we see that? That's what we need to answer. Here's another one. Here's a fern. Beautiful. This is a coal seam right here. You can see how perfectly flat it is here. We're going to answer why this is like this. This is called a turbidite. This is a model that shows underwater mud flow. And here you have, in 1929, there was an earthquake in North America, and a piece of the continental shelf broke loose. Boom. Everything was shifting down. It roared under the ocean, breaking cables as it went, so they knew exactly how fast the mud was going. They could track how fast it was going. At 3 hours and 3 minutes, this mud was 300 miles out to sea. That means it was moving underwater at 100 miles per hour. Now, what would happen if you were some little creepy crawly or fish or something, and this material hit you underwater at 100 miles an hour? What would happen to you? You would be fossilized instantly. That's how fossils are made. And what happens here is the sediment gets turned and stirred up, and the lighter stuff falls slower, the heavier material goes down quicker, so you see it hitting in layers. The Grand Canyon is graded coarse to fine, it's in layers. Heavier sediment goes to the bottom first, and the lighter particles rest. That means that the Grand Canyon happened in a very short period of time. This is a desert dune in Zion National Park. Scientists claim that it has always been a desert system, but after long periods of analysis, they determined that it was formed underwater. The angle of the deposition and the grain size proves that these deposits are also underwater deposits, not desert dune systems as previously assumed. So this happened underwater. How does something that tall happen underwater? Very interesting. Let's assume that you have a landscape here. It's not the mountainous landscape that we have today. And then there's some sort of depression. There's a continental depression. Land goes down, water flows in, and this is bringing sediment. This is bringing marine material in with it. And then there's an upheaval. This is how we explain seashells and other fossils at the tippy top of mountains. When I was out in Arizona, I used to live down at a border town at Bisbee, and everybody was into rocks and geology and fossils there, and nobody there could understand how you get fish fossils and seashells up at the top of the mountains. Well, one answer to that would be a worldwide flood. Another answer would be these great movements in the earth bringing the material in. And all this had to happen relatively quickly. Here in the Grand Canyon, you have Coconino sandstone and Hermit shale. You can tell them nicely apart because of the two different colors there. This is what's called a flame. Okay, this is two layers of rock, and something came through and whipped it up and brought those two together. How did that happen? Both of these material had to still be pliable when it happened. Simply came by and whipped up the mud together. Here you have a top layer depressing down into the bottom layer. You don't see any signs of breaking or anything, and that's impossible unless both layers were soft. And this is consistent with a worldwide flood where the material was deposited and shifts as it's being deposited. Here you have a mountain range. Could I fold a mountain range like this? All this had to be still wet, still wet when it was happening. Now, science says that this was rock, and then there was a superheated, and then it was superheated, and continental depression, and then it mutated it like that. The problem is that there's no signs of heat, there's no carbon or anything to suggest that it was heat. All that had to happen while it was still mud, and then it hardened like that. Here you have a finger of rock sticking up here, and it's hard, and all the rock around it has eroded away, but this rock still stands straight up. How do we explain that? What happened was the material was still mud, something came by, pushed up another material of mud, and it came right up through the layers and hardened. Now, if the layers of rock were solid rock, how could that happen? Now, I'll give you an experiment to do at home, right? Take a piece of glass, take a tube of toothpaste, shove it up to the glass, and squeeze the toothpaste out. What's going to happen? It's going to go all over the place. It's not going to go through the glass unless the glass was still soft enough for it to shoot up through. That's how we explain that. This is how erosion happens. This is the Orange River Canyon. Notice the distinct V shapes here. V shapes are indicative of rapid washout. U shapes are slow washout. V shapes, it happened rapidly. And this is what erosion does. Tears it out quickly. Here you have a gooseneck on the Colorado River. Even at the gooseneck, you have V shape on both sides. If this happened over a long period of time, you would have the erosion taken out here, and you would have the deposit all on one side, except we don't see that. It's V-shaped the entire way around. That means that that was carved out quickly. So is the river there because of the canyon, or is the canyon there because of the river? Interesting, isn't it? We're going to see some interesting things here with Mount St. Helens pretty soon. This is what's called a water whirl. Water sucked this feature out while the rock was still pliable. This is up at the tippy top of a mountain. How does that happen? Science says that there was water, and then a rock got caught in there, turned and ground that away. But how does it happen at the top of a mountain where there's no water? Now we're starting to see. Here you have Monument Valley. Anybody here been to Monument Valley? That's one of my places I want to go see. You been there? Okay. At one point, this was all flat sheets here, and something happened and took away everything else. What was it that took that away? Everything's gone here except these. They choose to just stay there over the millions of years and everything else goes. Why? Why does it happen? Here you have a riverbed, and this is a miniature formation, kind of a miniature example of Monument Valley, and this was taken in South Africa. What happened here? This was done in one rainstorm. There was a heavy rain, water came down, carved out the landscape here, and it was taking material out, but before it could take everything out, the water ceased. There just wasn't enough water to take everything away. How does this happen? See, the rest of these landscapes were just on a larger scale because the flood was on a much larger scale. And that's how we explain huge carved out regions like that. How do you explain that there's no water here at this time? What is it that carved all that out? So either millions of years did this, or a rapid flood did it while the material was still soft. Here you have, I think it's called the Town Hall Formation. There's an entire mountain above it. What is it that tore through here? And there's no water there today. So imagine this, what happened is that you have these layers of mud from the change in the earth and the landscape and everything, the layers of mud, and then the water starts to drain off the land. As it's draining off the land, it's tearing through the bottoms of these mountains. But before it can tear everything away, the water ceases. Had there been more water, that mountain would be gone. Let's continue. That's how we explain rock formations like this, where you have one little rock up there. There's a rock formation in near Raystown Lake, and it's called the Tipping Rock. There is a huge rock, probably the size of this table, and it's up kind of on a point just like this. And it's a mystery as to how that happened until now. Now you know how that happened. The water came down, washed everything away, but before it could wash everything away, even that tippy-top rock, the water ceased. Take a look at this. This is an example of the Mount St. Helens eruption.
A magnitude 5.1 earthquake causes the north face of the mountain to collapse, triggering the largest landslide in recorded history. Pressure rising from deep within the volcano rips open the mountainside, toppling entire forests, scorching everything in its path.
Okay. The Mount St. Helens eruption, I mean, don't get me wrong, it was a catastrophe, but it was great for science. It was great to learn from what could take place there. Let's take a look at, this was a mushroom cloud explosion. And by examining this is Mount St. Helens here, by examining this, we can better understand what happened in the past. At the beginning of the Mount St. Helens eruption, it was the north side that blew open, and then that entire face slid down. And I believe it was the largest landslide in history, in recorded history that we know of. You know what mostly comes out of a volcano? 70% of what comes out of a volcano is water. Water blowing out. And what does that do? As the water is blowing the superheated material out, comes down, lands into the lakes, what happens? Superheats the water, bam, blows it out, carves out the landscape just like this. When volcanic debris fell into the lake here, it caused tsunamis and washed this canyon out. And if this were observed, if we didn't know about Mount St. Helens eruption and this were observed and studied by scientists, this would have been dated at millions of years, wouldn't it? But this happened in a matter of seconds. Look how tall this is. There's a man there for size comparison. The Grand Canyon must have formed under similar circumstances. It's just on a larger scale because the events were just far larger. And I have an entire presentation. If you want to know more about the flood and really what took place with volcanoes, request through my website. I'll email you a video that I did that goes far and more in depth on the flood. But as the material was coming down, the water, the rock and everything, as it was coming down, it's tearing trees out of their spot. They're rolling against each other, and it's debarking the trees. Notice there's no bark on it, there's no roots on it, and all the material you see here. Now we start to see how the coal beds were formed and why they're perfectly flat like that. And then all the material sinks to the bottom, and then if this were a bigger waterway, all of these trees would be in the same direction. In given time, what happens is they go vertical just like this. All the bark and everything goes straight to the bottom. This is how these coal beds are formed. Outside of the Museum of Natural History at the Smithsonian Institute, there is this example of petrified wood right here. And this is dated at, it says, about 200 million years old. I took that picture and I was interested and I said, that's fascinating. How do they know that it was 200 million years old? Now we can look at other examples, and that was from Arizona. Here's an example of petrified forest. Now this is fascinating to me because what science teaches is that the tree would have been there through millions of years. It's going through several layers of time there. That's a very patient tree to wait there, to not be blown down, broken down, or to be decomposed. It just stands there for millions of years. Notice there's no bark, there's no branches, there's no roots. This happened in the same way that Mount St. Helens happened. It was just a larger, because what happened earlier was a larger example. And some of you may say, well, fine, Brandon, I'll give you the tree standing up thing, but surely that mud around it, surely that would take millions of years to form into rock. Is that the case? This was the island of Surtsey, born of fire and lava in the North Atlantic near Iceland in November 1963. The infant island of Surtsey demonstrated the ageless power of volcanoes to add new land to the surface of the earth. You could watch an entire island be formed before your eyes, and now there's even living material on that island as well. Take a look at this. I love this headline here, believe it or not. How many of you can make out what this is here? That's a bell encased in stone. In 1852, the Isabella Watson, a wooden ship, sunk off the coast of Victoria, Australia. The bells from the ship were discovered in the 1990s, early 90s, and you can see the rock encasing here. So evidently, for rock to form, it doesn't necessarily require these large expanses of time, these millions of years. This rock formed around this bell in about 150 years. Here we have an example, and this is a hammer encased in stone. So we have two options here. Either the bell is millions of years old, or the rock is not. Either the hammer is millions of years old, or the rock is not. Either the teddy bear is millions of years old, or the rock is not. This is from the dripping well of Knaresborough, England, and this has been dripping since 1630. You can actually take some of your own material there even today. You can hang it, and eventually it will be encased in stone. It will be fossilized. Here's a hat that was placed there in 1853, and it's very similar to the petrified water wheel here in Australia, and that happened in a matter of a decade or so, I think. Larger porous items like teddy bears and clothing take about 12 months or so to fossilize, to be encased in stone. Non-porous items such as a hat, a fireman's helmet take about 18 months to be encased in stone. So, does it take millions of years, or can it happen in a shorter period of time? How does this happen in a shorter period of time? It's just that the right materials are running in the right place to be able to cause this. Anybody here ever been to Luray Caverns? That's not very far away from here. I guess it is a few hours away. It is a beautiful display, one of the best displays in the world from what I understand. And if you go there, you will hear from a nice tour guide that these stalagmites, or stalactites because they stand tight to the wall, right? And stalagmites are on the bottom because they stand mighty. Takes millions of years for these stalactites and stalagmites to form. This is a supersized stalagmite that formed when water rich in calcium carbonate was pumped into a city. It took only months for this to form, yet if a scientist observed this later, after knowing how long it took, it would be dated at millions of years old, wouldn't it? Yet, there it is. This is an example of malachite. Malachite is a semi-precious stone. It's a ritual stone used in Africa by witch doctors. This is a 12-centimeter piece worth about $26,000. And this is the story, that a person ordered this from a dealer out of the Congo, and when it came to him, it was broken. And he called up his scientist friend and he said, "Scientist friend, my $26,000 piece of rock is broken, except there's something weird. There's a piece of copper where the finger broke off." And he said, "I'll be right over there." And he went over there and he looked at it and he said, "This is fascinating to me." And he said, "Is it okay if I take your $26,000 piece of rock and I break another finger off of it?" The guy literally burst into tears, $26,000. And he conceded. He said, "Yes, go ahead." What do you think they found inside the other finger? Found another piece of copper. Why is this? So he said, "Where did you get this from?" The guy said, "I ordered it out of a dealer in the Congo." He said, "Get him on the phone now. Let's find out if they have more of these." And the guy called the Congo dealer, and he said, "My $26,000 piece of malachite came and it's broken, and I want another one." The dealer said, "There's no more. We don't have any more." And then he turned to his scientist friend. He said, "I don't have any more." And then the scientist friend said, why didn't you ask him how long it would take to get another one?" So he said, "Well, how long would it take to get another one?" He said, "About 6 months." That's fascinating. 6 months, evidently, it takes to grow a $26,000 piece of malachite. Now, what happened here? Obviously, somebody figured out that if you hang copper and if you put the right material over it, it fossilizes, turns to stone, and you've got yourself a business there. Take a look at this. Romans chapter 1, verse 20. "For the invisible things of him from the creation of the world are clearly seen, being understood by the things that are made, even his eternal power and Godhead, so that they are without excuse." Now, what is the author of Romans here saying? The author of Romans here is saying, if you look outside your window, you just may find evidence of a creator. You just may find that there is something that has been withheld in the school system, maybe even.